Hello again. Welcome to College Algebra. We're going to talk about a new topic today. We're going to talk about the inverse function. So if we have a function, how can we reflect the function to get the inverse of this function? In other words, to make the domain range and the range domain. If we go from A to B, how to go back from B to A? So this is the definition of the inverse function. Before going to the inverse function, we have to discuss some properties or some conditions that must be in the inverse function. The first property is that the function must be one-to-one. What does one-to-one mean? So before we talked about the function is, or each x has only y value. For example, x squared, each x has only one value. So that means that x cannot have two values. On the other hand, a function like that, it's a graph like that, just a relation. Here's x has two y values. So this is not a function, but this is a function. Now, the new idea is one-to-one. One-to-one says that each x has only one y value, and each y has only x value. So the opposite, each y has only, or is assigned to only one value of x. So let's explain that in more details. So the definition of one-to-one function says that f is one-to-one if f of a equals f of b, then a equals b. In other words, that if y1 equals y2, then x1 must be equals to x2. For example, if I have a function like that, each x value or each y value has one x, each one value has one x, y value has one x. On the other hand, if we go to the function like x squared, each y value, let's say this is 4, has two x values. So that is not one-to-one. This one is one-to-one. If we're going to compare and contrast between how to define a function by the virtual test, we have two ways. We talked about for the function, we use something like that. We use a vertical line as a test, and if the vertical line intersect with the relation in more than one point, that wouldn't be a function. For one-to-one, if you want to check one-to-one, you don't use vertical line but horizontal line. So we learned before that this is not a one-to-one function. So if you use a horizontal line, you're going to find that this horizontal line intersects the function in 2 points. So this is not one-to-one. Alright, so let's get an example and see whether this function is one-to-one or not. So I have f is 3, 2, 5, 8, and negative 1 and 8. Let's make this like the domain, or this x and this is y. And I have 3 that is connected to 2, and I have 5 connected to 8, and I have negative 1 connected also to 8. So two x values connected to one y value. So that disagree with the definition that each y value is assigned to only one x value. So I have 8 is not assigned to only one x value, but it's assigned to 5 and negative 1. Therefore, f is not 1-to-1. Let's get another example. I'm gonna get similar example here. The g is negative 5 and 3 and 9, 2 and 0 and 15. So again, I'm gonna make x and y. I have negative 5 assigned to 3 and 9 assigned to 2 and 0 assigned to 15. So based on that, each y value is assigned to only one x value. Therefore, this is 1-to-1. Okay, so we talked before about the horizontal line test. So we're going to test some shapes and see whether these functions are 1-to-1 or not. So let's graph this one. Is this a function? Is this a function? Yes. If you got a vertical line, it shows that it's a function. Is it a 1-to-1? So let's get a horizontal line here. So this horizontal line intersects the function in 1, 2, 3 points. Therefore, this is not a 1-to-1 function. Let's get another one, and we went through that before. Horizontal line, it intersects the horizontal line in one point, so this is 1-to-1. One more. Horizontal line, more than 1 point, so not 1-to-1. Another one here. Take the horizontal line and it intersects the function in only 1 point. Therefore, this one is 1-to-1. Alright, so a new concept, we know about that. So now we test the function, whether it's 1-to-1 or not, by the algebra test or the algebraic test. So, based on that definition, if f of a equals f of b, then a is b. So I would check the function, I plug a and b in the function, and test if I get a equals b. So let's get another example about that. I want to test that f of x equal 3x minus 4 is 1-to-1 or not. So I would get f of a equal f of b. So what's f of a? I plug a here, so I have 3a minus 4, and I plug b here, I have 3b minus 4. Okay, add 4 to both sides, so I have 3a equals 3b, and now we divide by 3 both sides, so I have a equal b. Therefore, when f of a equals f of b, then a equals b. Therefore, f of x is 3x minus 4 is 1-to-1. Okay, one more example. Let's say g of x is x squared. Okay, we start with f of a equals f of b. Okay, a and x squared, that would be a squared, is f of b when, I'm sorry, this is g. You got used to use f all the time. So g of a is a squared and g of b is b squared. Now I have squared, I take the square root of both sides So I have a on the left, but here I have plus or minus b. Therefore, a has two values, b here, so this is not, a is not equal b. So therefore this function is not one-to-one. Okay? I hope that this test is clear. Alright, now before I started in the beginning and I said that this property, the one-to-one properties, is needed or is required for the inverse function. Now we're going to start about the inverse function, how to find the inverse function and how to find the domain and the range of the inverse function. How to test that the function has an inverse or not. Okay, so we say that let f is one-to-one function, then g is an inverse of f if, number one, f of g of x equals x, and g of f of x also equals x. So when I compose f of g, it must be x. And when I compose g of f, that also must x. Therefore, g is the f inverse, the function of f. And this -1 does not mean this is not is -1 is not an exponent. So here I mean -1 is the inverse of f. So g is the inverse of f. Okay, let's get an example and test whether g is the inverse of f. So I have f of x equal 3x minus 4, and g of x is x plus 4 over 3. So now, in order to test that g is the inverse of f, I test f compound g and g compound f. And I must get x in both sides. Okay, so let's try f compound g of x, which is equal, as we learned before, f of g of x, where g of x is the inner function, so that would equal to f. And what is g of x? X plus 4 over 3. And as I told you before, we put the pattern here to compute the function. So x, I'm going to make parentheses and minus 4, and then I plug x plus 4 over 3 here. Let's distribute that. 3 with 3 is cancelled out, so I have x plus 4 minus 4, and 4 and -4 is cancelled out, so I have the answer is x. So far so good. So I have half of the solution is okay. I'm going to test the second one, is g of f of x. So this is equal g of f of x. But what is f of x? F of x is 3x minus 4. So I have g of 3x minus 4. And now I put the pattern of g. So the pattern of g is 3, and here is x, and here's plus 4. And now I plug this input here, which is 3x minus 4. Okay, so now I have on the numerator 3x minus 4 plus 4 over 3. So -4 and 4 is cancelled out, and I got 3x over 3, which is x. Now, I have f of g of x is x and g of f of x is x. Therefore, the g is the inverse of f. Okay? I hope that this example is clear. And before going to another section. So the next thing we're going to talk about that. Okay, I know that this is g of x is the inverse of x. How can I find the inverse of a function? So in order to get the inverse of a function, I knew that from the beginning that the function must be one-to-one. So the first condition is the function to be one-to-one. There are some steps is how to compute or find the inverse function. I'm going to go through them one by one right now. Okay, number one, replace f of x by y. Number two, interchange y by x. And three, solve for y. And finally, replace y by f inverse of x. Alright, so let's get another example about that. We need to find the inverse of f of x equals 2x minus 3. So let's see, the first thing, I replace f of x by y. So y equals 2x minus 3. That's step one. Step two, I exchange or interchange y by x and x by y. So that would be x equals 2, y minus 3. Step three is to solve for y. So I'm going to add 3 here. Add 3. So 2y is x plus 3. And divide by 2. So y equals x plus 3 over 2. Therefore, the last step is to replace y by f inverse. So therefore, the inverse function is x plus 3 over 2. Okay? And also you may test that by doing f compound f inverse and f inverse compound f, and what should we get? X. Alright, let's get another thing. Before we go to this function, to the second function, I need to explain something here. That the inverse function, the function and the inverse function are reflected about y equals x. So it is y equals x. Okay, and here, I go here the negative 3 and 2x must be that way. That is one function. This is 2x minus 3. The reflected function should be that way. I mean that the inverse function is reflected. So if you see that this part is reflected, like that part here, about y equals x, and again here it's reflected about y equals x. I think that the graph is not clear. Maybe I'll make it this way. So this distance must be the same. Okay, let's get another example here. I have f of x equal the square root of x minus 3. I need to get the inverse function of that. Okay, so the first step, replace f of x by y, and then interchange y by x and x by y. So x is the root y minus 3. The third step is to solve for y. So this is under square root. In order to solve for radicals, I take the square root of both sides. So I have y minus 3 is x squared. And now I'm solving for y, so I'm adding 3 to both sides. And I have here y is x squared plus 3. Now I replace y by f inverse of x. So f inverse of x is x squared plus 3. Now let's graph both of these and see how they reflect about y equals x. So here I have, this is y equals x, and I'm going to graph this one. So this is the square root of x minus 3, square root of x, that way, but I have to shift it 3 points to the right. So here is 3, and that must be this way. So this is root x minus 3. Now the second one is x squared plus 3. So I'm going to go here, 1, 2, 3, and that would be x squared plus 3. Alright, now let's think about that. Is this reflected to that one? No, this part is reflected to that part, but how about this part? Remember, what is the condition of the inverse function? It must be 1 to 1. Is this function 1 to 1? No, it's not 1 to 1. So what should I do to make this function 1 to 1? I have to remove the part here, and I restrict the domain. The domain is from 0 to infinity. So instead of from negative infinity to infinity, I have to restrict the domain from 0 to infinity. Why? Because the function must be 1 to 1. Okay? And here is the domain, and here is the two functions. Therefore, the f inverse of x is x squared plus 3, where the domain is the 0 to infinity. And we see how they reflect about y equals x. Let's get the last example for today. And this is application 1. So again, we're going to find the inverse function for an area of a square. The area, a of x, is x squared. I want to find the inverse function and find a inverse of 25. Okay? So this function explains the area of the square. Alright. So now, in order to solve that, I'm going to use the 4 steps. So I'm going to call this y equal x squared, and then interchange. So I make this x equals y squared and solve for y. So I take the square root of both sides. So y equals plus or minus square root of x. Here's the thing. That cannot be a function. Okay? And if you think in terms of the area, you can't have a negative area. So in order to make this a proper function, that's number 1, and make it 1 to 1, I have to remove the negative and make only the positive one. So now the function y is the square root of x, which means that the area inverse of x is the square root of x. Now, I need to find the area inverse of negative 5, of 25. So that equal to the square root of 25, which is 5. So now, that makes sense because the square root of the area, so this is the area, is 25. Okay, the inverse of 25, if we interpret that, that would be the size of the side here, which is 5. You can say geometrically that this side is negative 5. So that's why we eliminate the negative here to get a positive here. And this is the end of the section. I hope that everything is okay today, and thank you and have a good one.